The closest solar system to us is Alpha Centauri, which includes two large stars A and B. Small faint red dwarf star that is closer to us and is 4 light-years and a quarter away from us. For this reason, the red dwarf was given the name Proxima Centauri. Proxima Centauri b was discovered in 2016, is a super-Earth exoplanet that orbits an M-type star. Proxima b mass is 1.27 Earth. It takes 11.2 days to complete one orbit of its star, which is less than a tenth of the distance between Mercury and the Sun in our solar system. Mercury, the planet closest to our Sun, is 55 million kilometers from it and completes its cycle around it every 88 days. Welcome to the SpaceWind YouTube channel. In this video, we are going to talk about new discovery on Proxima b and also the new discovery that helps astronomers detect space weather. So before starting this video, like this video and subscribe to our YouTube channel for future updates. A team of astronomers, made up of 31 scientists, reaching the existence of the planet Proxima b, while using the European Southern Observatory's Very Large Telescope in Chile. Recently, astronomers noticed the proximity of the planet Proxima b to our Earth, and it was considered that it is among the 3,600 planets that was discovered are located very close to Earth and are outside our solar system. NASA discovered 2,000 exoplanets between 1995 and 2015, and at the end of this year, the total number of planets discovered so far exceeded 3,500. The nature of the red dwarf star is considered one of the most important challenges facing the possibility of life on the surface of Proxima b, as the mass of the star does not exceed 12% of the mass of our Sun. Its brightness is 0.1% of its brightness, which means that Proxima b should be 25 times closer to our Sun, its star compared to our Earth where we live, the distance from the Sun to the orbit within the life zone. As is known, our Sun has a density of 1.41 times the density of water, while Proxima b has a much higher density, 56.8 times the density of water and 7.23 times the density of iron at standard temperature and pressure, while its mass is 129 times greater than that of Jupiter. Due to its increased density, its diameter is only 1.5 times that of Jupiter, and below is a comparative side-by-side of Jupiter, Proxima Centauri, and our Sun. It has a diameter of 200,000 kilometers versus opposing Jupiter's 143,000 kilometers. Scientists study aspect of habitability, which is atmospheric loss in the context of stellar physics. Planets have lots of different interacting systems. Ofer Cohen said, the question is, how much of the atmosphere is lost, and how quickly does the process occur? If we estimate that time, we can calculate how long it takes the atmosphere to completely escape, and compare that to the planet lifetime. Ofer Cohen is a space scientist at the University of Massachusetts, Lowell, and co-author of the study. According to the document, with the highest thermospheric temperatures and a completely open magnetic field, Proxima b could lose an amount equal to the entire Earth atmosphere in 100 million years, and that's just a fraction of the 4 billion years of Proxima b so far. Recent studies show that the planetary magnetic fields can prevent direct stripping from the planet's atmosphere by stellar winds, but escape of ions can still occur at the magnetic poles. Roughly 3/4 of Proxima b possible simulations actually produce a magnetic field that lasts for at least 3 billion years. Scientists Zuluaga and Bustamante wrote, believe there is a good chance that Proxima b has a magnetic field similar to that of our Earth and is even capable of protecting the surface of these planets. Hence, the planet Proxima b has an exciting opportunity to contain life. Astronomers recently discovered that M-dwarf stars pose a particular danger to their planets. Much of its radiation, much more than that of Sun-like stars, is in the form of ultraviolet, and X-rays. A team of 12 Australian researchers has shown for the first time a definitive link between light flares and radio bursts on a star other than our Sun. This star has a radius of 14% of the radius of our Sun, a mass of about 12% of the Sun, and an effective temperature of only about 3050 Kelvin, 5031 degrees Fahrenheit. Given Proxima Centauri is a cool small red dwarf star, it means this habitable zone is very close to the star and is much closer in than Mercury is to the Sun. A new discovery makes life on other planets less likely than previously thought. That the region of red dwarf stars is deadly radiation. Subsequently, Proxima Centauri does not promise to find life as we know it. It would exclude the habitable regions closest to Earth, which would be around stars much smaller than the Sun. Dr. Andrew Zick said, "We have recently found there are 2 Earth-like rocky planets around Proxima Centauri. One within the habitable zone, where any water could be in liquid form." Dr. Andrew Zick is an astronomer in the School of Physics at the University of Sydney and CSIRO Astronomy and Space Science. So if the night side of Proxima b is illuminated by artificial light, could we detect it with Hubble Space Telescope successor? K218b. Known as Super-Earth, the planet orbits in the habitable zone of its star. Its mass is 8.92 Earths. It takes 32.9 days to complete one orbit of its star. Scientists have detected water vapor in the atmosphere of K218b. While its atmosphere could contain a large amount of hydrogen or helium, it could also be a water world. Angelos Tsiaras said, "This is the only planet right now that we know outside the solar system that has the correct temperature to support water, that has an atmosphere, and that has water in it." Angelos Tsiaras is an astronomer at University College London. Scientists predict that the approved Cycle 1, the James Webb Space Telescope observations of K218b, a candidate Hycean planet, will be able to detect these biomarkers if present at the quantities considered in this work. According to the document, that the James Webb Telescope requires 2 transits if the NIRISS and NIR spec data are combined. So this makes K218b an ideal atmospheric target for the capabilities of the next generation of space infrared observatories to provide a complete picture